Today's topic is redox reactions. That is from Unit 2, AS Chemistry. First, the definition of oxidation and reduction, how we define oxidation and how we define reduction. So you can learn from the term oil rig, in which O stands for oxidation and I stands for is. And what is L? L means it has a loss. Loss of what? Loss of electron. Means if something will lose electron, what we call that as oxidation. What about reduction? R rig here, R stands for reduction, I stands for is, and G stands for gain. So when something gain electron, we call that as reduction. And a reaction in which both happen, like oxidation and reduction happen, we call that as redox reaction. So in this topic, we will discuss the oxidation numbers and identifying the changes in oxidation number, and using the change in oxidation number, we can identify whether there's an oxidation or reduction or if there's no change. Now, rules of assigning the oxidation number. Oxidation number, it is a charge appear when two or more elements form a compound. We call that as, that charge on the element is known as oxidation number. But in the element state, when it is not combined with any other, like two different atoms are not combined with each other, so in element state all have oxidation number 0. Like example, zinc as an atom exists as an atom, atomic so oxidation number is 0. Chlorine is also an element, exists as a molecule, so oxidation number will be 0. Oxygen, a molecule, oxidation number is 0. So in element state, the oxidation number is 0. For a compound, for a neutral compound, because we can have molecular ions or we have a compound. So when there's a compound, the oxidation number, the resultant oxidation number or sum of oxidation number of the elements present in a compound, the final will be 0. Like if we say sodium chloride, so sodium chloride is NaCl, it's a compound. So what could be the oxidation number of sodium and chlorine? Because the overall compound oxidation number is 0. How we can work out the oxidation number of the elements? So for that, we have to use the group numbers. So with reference to the group number, we can mention or we can say it's oxidation number, but it is not always true that the group number is oxidation number, especially for the non-metals. So basically they have a range of oxidation numbers. If we have example, we have group 1, group 2, group 3, 4, 5, 6, 7, and 8. So group 1 metals are there. Group 1 tend to lose 1 electron. Group 2 tends to lose 2 electron. Group 3 tend to lose 3 electron. That's why positive oxidation. Group 4, a non-metal, -4, -3, because to complete octet, it takes 3 electron, -2, -1, and already octet is complete except for helium. It's a complete shell, the first shell. So oxidation number is 0. But they may have, because group 4 is having 4 electrons, so maybe it will gain 4 electron or share 4 electrons, so that is why negative, or maybe it will lose. That is a possibility. So it may have +4, this may have +5, this may have +6, this may have +7. So what does it mean? For group 4, the oxidation number can vary from -4 to +4. Means they can have value from -4 to +4. Commonly is -4, but it is not always true. It can have maximum till +4. For group 5, commonly it is -3, but it can have till +5. So from -3 to +5, it does not mean like either it will have -3 or either it will have +5. No, it can have oxidation number from -3 to +5. For group 6, so -2 is there, or it can have +6. So any value from -6 On a number line, -1 to +6 is valid. For group 7, it is -1 to +7, that is valid. So example, if we want to work out the oxidation number of the chlorine in a compound NaClO3. So we have a compound NaClO3, and the one which is unknown, example, there is no charge, so it's a compound, so neutral. Now we want to find for chlorine. So for chlorine, we will assume unknown X, and for like sodium and oxygen, we'll take their common oxidation number. Like for sodium belongs to group 1, so it will be +1. Chlorine, we don't know X. And for oxygen, the common oxidation number is -2, and how many are there? 3. So that is -2 multiplied by 3. And the sum of the oxidation number for the compound, that total sum should be 0. So if the total sum is 0 when I solve the mathematical equation, so it is 1 plus x, and actually -2 is multiplied by 3, so it will be form -6 equal to 0. So x -6 plus 1, that is equals to -5 equal to 0. So x is equals to +5. So in this compound, this is called sodium chlorate 5. Why it is known as sodium chlorate 5? Because the oxidation number of chlorine is +5. So I told you that chlorine, even it belongs to group 7, common oxidation number is -1, but it can have maximum +7. But it does not mean like either -1 or +7. It can have oxidation number from -1 to +7. Positive sign shows that the electrons are being like shifted from chlorine to another element, and negative sign shows that electrons are shifted from other element to chlorine. Is it clear this example? The oxidation number of this chlorine in sodium chlorate 5. Any doubt in this part? Same way, another example, if I say NaClO, what is the oxidation number of the chlorine in this compound? NaClO. So chlorine is unknown, so sodium is +1, chlorine is unknown X, and oxygen common oxidation number is -2. So X +1 -2, that will make -1. So it will be X is equals to +1. So when you represent the oxidation number, the sign is also important, positive and negative. So you should consider the signs as well. Like writing the answer, it should be with sign. Same way, the oxidation number of a monoatomic ion is equal to the ionic charge. Like example, basically, if we have not about the complex, like no, so normal, like example, if sodium chloride, so oxidation number of sodium is +1. If it is magnesium chloride, the oxidation number for magnesium will be +2. If it is aluminum trichloride, oxidation number of aluminum will be +3. So the charge of the ion is same as the oxidation number for ionic compound. But for polyatomic ions, the sum of the individual oxidation state element lead up to the charge. Like why we say sulfate is -2, carbonate is -2, nitrate is -1. So what is the reason behind that when we are writing the valencies of for these molecular ions? So example of nitrate, for nitrate we used to write -1. So what is the reason why nitrate is -1? Because what happened, each oxygen is -2, so 3 oxygen will be -6. So this -2, just a minute. So this minus 2 multiplied by 3, that is for oxygen, plus, because the final, for example, nitrogen we don't know. So it is x and the total is minus 1. So x minus 6 is equals to minus 1, or minus 6 move other side, minus 6 minus 1 plus 6, that will give plus 5. So what is the oxidation number of nitrogen? Actually nitrogen is plus 5. So each oxygen is minus 2, but 3 oxygen will have total of minus 6, and nitrogen is plus 5. That's why the total charge, the total resultant oxidation number leads to the charge on the molecular ion or polyatomic ion. Same way if we are writing sulfate. So sulfate, how the charge on sulfate is 2 minus or minus 2. One oxygen is minus 2, so 4 oxygen will be minus 8. So what should be the oxidation number of sulfur in this sulfate ion? To get the result minus 2. What is the oxidation number of sulfur to get the whole? So it should be plus 6, because plus 6 minus 8 will result in a minus 2. Same way, if I write sulfur sulfite ion, SO3 with a charge minus 2. So one oxygen is minus 1, minus 2, so 3 oxygen will be minus 6. So to get the result minus 2, what should be the oxidation number of sulfur? It is plus 4. So sulfur belongs to group 6. So sulfur belongs to group 6. It can have minus 2 to plus 6. That plus 6 is a maximum. It can have any oxidation number between minus 2 to, from minus 2 to plus 6. So for metals of group 1, the oxidation number is plus 1. For group 2, plus 3. For hydrogen, like except for metal hydrides, what is, why is less as minus 2? Which one you're saying? For sulfur? Because sulfur belongs to group 6. So what are the possibilities? As it belongs to group 6, the possibilities that to complete the octet, it can take 2 electrons. If it take 2 electrons, the charge will be minus 2. And what is the second possibility? That it might lose all of its 6 electrons. So if it lose all of its 6 electrons, what will the maximum charge? It will be plus 6. So if you want to work out the oxidation number, common, these are the common oxidation number for group 1 metal, all are plus 1. Group 2, all are plus 2. Aluminum is plus 3. Hydrogen is there, it's plus 1, except the metal hydrides, in which it is negative, minus 1. Fluorine is minus 1. Chlorine, bromine, iodine, minus 1, except with the compound oxygen and fluorine, because oxygen and fluorine are more electronegative, so they tend to gain electron easily. That's why the oxidation number will not appear as minus 1. And for oxygen, it is minus 2, except for peroxides, where it is minus 1 and compound with fluorine. So these are some exceptions. Now we will do some examples how to work out the oxidation number. For example, iron FeCl3. What is the oxidation number of iron in FeCl3? So how to work out, because this overall is neutral, so iron is unknown X. Plus, there are 3 chlorine and each chlorine is minus 1 and the total result is 0. So x minus 3 is equals to 0. If x will move other side, it will be plus 3. So oxidation number of iron is plus 3. Then identifying the oxidizing agent and reducing agent. So for a substance which oxidation happen is known as a reducing agent, or you can also say reductant. And for a substance which reduction happen, that is known as oxidizing agent, also known as oxidant. So example, we have a reaction between bromine and iodine. Bromine and iodine are reacting with each other, form bromine molecule reacting with iodide, result in a formation of iodine molecule and bromidine. Always the more reactive halogen displaces a less reactive halogen from its compound. Now to identify which change is oxidation, which one is reduction, so better write the oxidation number. So what is the oxidation number of the bromine? What is the oxidation number of bromine? So oxidation number of a bromine is 0. And what is the oxidation number of bromide ion? The charge on the ion is same as the oxidation number, so it is -1. So if 0 is changing into -1, and when we are comparing the oxidation number, we compare for individual, for each atom, for each ion, we don't take the whole. So for bromine molecule, each bromine is having oxidation number 0, and in bromide ion, bromine is having oxidation number -1. So 0 changed to -1, what we call? If we have a number line, if we move towards right hand side on the number line, we call that as oxidation. If we move towards left hand side, we call that as reduction. So 0 changed to -1, what we call? Increase in oxidation number or decrease in oxidation number? Or you can also say increase in oxidation number is oxidation and decrease in oxidation number is reduction. So here 0 become -1, it is decrease in oxidation number. So you call that as reduction. And for substance which reduction happen, that substance is known as oxidizing agent or oxidant. Same way, when you check for iodine, iodine is -1, and this iodine -1 changed to iodine element 0. So -1 changed to 0, it means increase in oxidation number. If there is increase in oxidation number, we call that as oxidation, and the substance is known as reducing agent or reductant. So the definition of oxidation is same as reducing agent for this, and definition of reducing agent is same as oxidant. The definition of oxidation is same as reducing agent, and the definition of a reduction is same as oxidizing agent or oxidant. Is it clear, this change? So from the equation, you should be able to identify the oxidizing agent and the reducing agent. Another example, so you have zinc is reacting with copper ion, and because zinc is more reactive, so more reactive metal displaces the less reactive metal from its compound, so it displaces copper. So when we write the oxidation number, element state 0. For zinc, 0 become +2, so increase in oxidation number. If there's an increase in oxidation number, what we call this change? What is the name given to this change when there's an increase in oxidation number? So we call this as oxidation. And if this change is oxidation, The element for which oxidation happens, that is acting like a reductant or reducing agent. For copper, ion, it changed to copper atom. So ion is +2 changed to 0. So there is a decrease in oxidation number. If this is decrease in oxidation number, we call this change as reduction. So if this is a reduction, what copper is acting like? The copper ion. The copper ion here is acting like an oxidant or oxidizing agent. So from equation, you should be able to identify the oxidizing agent and reducing agent, or which change is oxidation and which one is reduction. Hydrogen peroxide, which is H2 and O2, decompose into hydrogen, decompose into water and oxygen. Equation must be balanced, so this is a balanced equation. So hydrogen peroxide decompose into water and oxygen. When we write the oxidation number for each hydrogen is +1, because when you compare whether it's oxidation or reduction, you compare each atom. For each oxygen, it is -1. How we work out? Because H2O is there, H2O2 is there. One hydrogen is +1, so two hydrogen should be +2. So because overall compound is neutral, so total oxidation number of oxygen should be -2. But that is a total for two. For individual or one, it will be -1. Same way, for water, when we write the oxidation number for water, which is H2O, each hydrogen is +1, so two hydrogen should be +2, so oxygen should be -2. So hydrogen individual +1, oxygen -2. And here it is an element, so it is 0. For hydrogen, when we check hydrogen before, for each hydrogen, the oxidation number was +1. And after the reaction also it is +1. So it means there is no change in oxidation number. But what about oxygen? Before it is -1, it become -2. One of the compound, oxygen, become -1, change to -2. So that is a decrease in oxidation number. If oxidation number decrease, we call that as reduction. And oxygen is -1, and there is another compound of oxygen which is 0. So it means that is an increase in oxidation number. Increase in oxidation number is called oxidation. So one of the reaction, oxygen is reduced, and another reaction, oxygen is oxidized. So, but both happen in the same, by a same chemical reagent. So this type of reaction is known as disproportionation reaction, in which the same element is oxidized and reduced. Here what happened in the previous example, zinc was oxidized and copper was reduced, different element. But here what happened, the same element is oxidized and reduced. Is it clear, this example? And the type of the reaction, the disproportionation reaction? Any doubt in this? Same way, example, if we write we have sodium chlorate, one, so change to NaClO3 and NaCl. This equation is not balanced, but I am explaining in terms of oxidation number. So when we write the oxidation number, one oxygen is -2, so sodium is group 1 +1. So chlorine should be +1, so that the overall compound is neutral. NaClO3, so one oxygen is -2, so three oxygen, one oxygen is -2, three oxygen will be -6. But we write for individual, so that's -2. Three are -6, 1 so that is +1, and for overall compound to be neutral, chlorine should be +5. This at the top I wrote individual, and at the bottom I'm writing the total. And sodium chloride, sodium is +1, chlorine is -1. So for sodium, when we check sodium, there is no change for sodium. But when we check for chlorine, it is +1. For oxygen also there is no change. +1 change to +5. So it is an increase in oxidation number. So we call that as oxidation. And +1 become -2, -1. So that is decrease in oxidation number, or we call that as reduction. So same element, chlorine, is oxidized, and same element, chlorine, is reduced. So these type of reactions are known as disproportionation reaction. Proportionation reaction. So example, when metal generally, when they form ions, they tend to lose electron, and non-metals, they tend to gain electron. So when lithium is reacting with oxygen, form lithium oxide. So lithium element oxidation number 0. Oxygen element oxidation number is 0. So both have say 0 oxidation, but form a compound lithium oxide. So when a compound lithium oxide is formed, one lithium is +1, so two lithium should be +2, and this should be minus. So, but we write for individual. So individual oxidation number for lithium is +1. Two are +2, but for one, each is +1, and oxygen, the only one is there, so that's -2. So oxygen 0 become -2. That's a decrease from 0 to -2. That's why we call this as oxygen is reduced, because its oxidation number decreased, and lithium is oxidized because its oxidation number increases from 0 to +1. And if some substance oxidation happen, that is a reducing agent. And for substance reduction, for a substance reduction happen, we call that as oxidizing agent. So here oxygen is oxidizing agent, and lithium is a reducing agent. Another example, you have a tungsten oxide is there, which is WO3, reacting with hydrogen. This result in a formation of tungsten metal plus water. So it shows that hydrogen is more reactive. That's why it is able to displace this tungsten. When we write for each oxygen, it is -2. So 3 oxygen will be -6. So tungsten should be +6. So individually +6 and -2. Element state 0. Element state 0. For one hydrogen, it is +1. Two hydrogen +2. Oxygen should be -2. So, but we write for individual. For tungsten, +6 change to 0. If +6 change to 0, for a tungsten +6 becomes 0, it means decrease, and decrease in oxidation number we call reduction. For hydrogen, 0 become +1. So hydrogen, that 0 change to +1, so increase in oxidation number, and we call that as oxidation. Is it clear? Then different examples are there. Now, how to balance a redox equation and writing the combined equation. How to write a combined equation by oxidation and reduction half equations. So from oxidation and reduction half equation, how we can write a combined equation. Now, what is the rule for this? There are steps which we will follow. Number one, first identify oxidation and reduction half. like which equation oxidation happen and which equation reduction happen. Second part, balance oxygen. And when we are writing a combined equation, this balancing, this writing a final or a full equation can be in different medium. This is in acidic medium. In alkaline medium also we can balance the oxidation half equation, write a complete equation. But first thing, it's in acidic medium. So balance oxygen by adding water molecules. Then balance hydrogen by adding protons or H plus. These are the steps which we will follow. Then balance other elements. Then balance the charge by adding electrons. Then make number of electrons same. For both equations, and then we will add the two equations. Or combine the two equations. Addition, or that depends on how you are adding, like combine the two equations. Example, I have MnO4 with a charge -1. It is changing into Mn plus 2. What is this change? Oxidation or reduction? MnO4 is changing into manganate ion, changing into Mn plus 2. What is this change? Oxidation or reduction? This change is actually reduction. Why it is reduction? Because you don't check for overall molecule, you check individual. Like when I write one oxygen is -4, so 4 oxygen will be -8. So Mn will be +7. So Mn is +7 and +7 change to +2. So that is reduction. So don't be confused with the charge on the ion, that this changes oxidation and which one. You have to check for individual elements, not the overall compound. So this is a reduction. And example, you have iron 2 changes to iron 3. What is this change? So now we have iron +2 change to +3. So that is oxidation. Now what we have to do, we have to write a balance equation for, or a combined equation for, from these two oxidation and reduction half equation. Now first we will take one of them, any one of them you can take first. Example, I have MnO4 with a charge -1 changes to Mn plus 2. Now what is the first? Identify the oxidation and reduction half, that we did. Balance oxygen by adding water. 4 oxygen on the left hand side. So how many water molecule I should add? So I will add 4 water molecules. 5 minutes left for this session. So this example I will quickly go through, and I will give another example in next session. So Mn is, oxygen is 4, so we add 4 water molecule. That is done. What about hydrogen? There are 8 hydrogen on the right hand side, so I need 8 hydrogen. To balance hydrogen, we add proton. So how many protons I should add? I should add 8 protons on the left hand side. So hydrogen is also balanced. Then balance other element, hydrogen is balanced, oxygen is balanced, and manganese is also balanced because one atom is there, both sides. Balance the charge by adding electron. So how to balance the charge? Here the charge is +8, -1, so it is +7. And here the charge is +2. So where I should add electron, because electron is a negative charge, so I will add an electron towards the side where I can reduce the charge. So I will add 5 electrons here, because when I add 5 electron, the meaning of 5 electron means it is -5. So -5 +8 -1. So what it will result? It will also give +2. So charge is also balanced. So this equation is balanced in terms of charge. It is balanced in terms of elements. Now what about the second equation? This was for reduction. The second equation was oxidation for iron, in which iron is +2 changes to iron +3. So it does not have oxygen, so we don't have to add water. It does not have hydrogen, so we don't have to add proton, and it does not have any other elements. Iron is already balanced. Now to balance the charge, we add electron. Here the charge is +2 and here the charge is +3. So we always add the electron to a side where the charge is bigger. So +3 -1, it will give +2. Now, to make or write a final equation, what we will do, we will combine the two equations by making the number of electrons same. So the first equation, I have 5 electron, but the second equation, I have 1 electron only. So what I will do, I'll multiply this equation by 5. So when I multiply this equation by 5, all are multiplied by 5. And then what I will do, I will add the two equation. When I add the two equation, electron number will cancel with electron. So we have, the result is, on the left hand side we have 8 protons, we have MnO4 with a charge -1, we have 5 Fe2 plus 2. On the right hand side we have Mn plus 2, 5 Fe plus 3 plus 4 H2O. So this is the balance equation. The reason why I quickly go through this, I will give more examples in the second part, the session. Because of the time, it's like a minute left. That's why I quickly go through this example. Is it clear? If it's not, then I will give another example or same example I'll repeat in the second session. Is it clear? Yes, I will repeat in the second part. I will repeat.